Destroy shit, pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
What's up, Earthlings? From time to time, I get a kick out of torturing myself by listening to some of the most intelligent, scientifically valid arguments from some of the top scientific minds over at the Brandon Toy, aka Ranty Flat Earth channel. Okay, let me stop with the obvious sarcasm. Anyway, on this particular occasion, Brandon asked an excellent question. It was such a good question, it almost sounded like Brandon was a globe earther for a second. Let's have a listen and see if we can't answer this question for Brandon.
And we've been looking at the sun a lot lately, and I just came across this and I thought, yeah, this would be good to talk about because it is pretty cool what you see in this. You see the sun kind of fade out there and this illumination distance. Now, this is what kind of caught my eye. The sun is clearly above the horizon here, correct?
No, you fail to realize the sun is already behind the horizon. That's just the remaining light.
Oh, shit. Yeah, I thought somebody might say something like that, but I'm looking at this and I think that the sun is still above the horizon. It's pretty dang bright for being behind the Earth. And another thing I noticed is it's dark right here down below this plane and around here. But there's the sun right there. Oh, how is that possible? How is it possible to have darkness right here and the sun above the horizon?
What's crazy is that he is so entrenched in his belief that the Earth is flat that he doesn't even realize that he's questioning a phenomenon that would only be possible if the Earth were a globe. Now, remember what I said about this being a great question? This is the same type of question I've been asking a lot of flat earthers when I bring up pictures like these, showing the actual Earth shadow. Questions like, what's creating this shadow? Why is the light being suddenly cut off? Let's go back to the video Brandon was questioning and see if we can't get some answers for him. Now, Brandon, there's a very simple explanation as to why it's dark in the foreground in this video. The aircraft is at an elevation where it's still in direct sunlight. The clouds are in darkness because they're in the Earth's shadow. This diagram kind of explains what's going on in the video. Airplane here, Earth shadow here. I can't make this any easier to understand. I really hope this answers your question, Brandon. But of course, flat earthers will make up some ad hoc explanation for this phenomenon in order to deny what's actually going on in the video. It's so funny how flat earthers get so triggered when you call them out for denying reality.
Okay, good. So you don't want to answer the question, you've conceded.
No, I'm telling you that you're going to deny reality, so go ahead and deny reality.
Oh, now I'm denying reality again. All right, I think we've had enough about you. Thank you very much, though, for coming. You can come tomorrow.
Clearly is that you're not here honestly. With honest
that's
intentions.
it. I'm done. That was 5 times he's told us that we're denying reality. I'm fucking sick of it. Thanks, Kosho. Thanks for coming.
Oh, and Brandon, just in case you need some help with trigonometry and figuring out how to solve a triangle, I brought my good friend Conspiracy Catz to try and explain it to you.
Okay, Brandon, now in the debate we had, you did seem a little bit upset when I mentioned that you might not understand what trigonometry is. And because you didn't understand what trigonometry is, you couldn't see the significance of the angles to Polaris and how they relate to the shape of the Earth. And you couldn't quite see just how poor the evidence was you provided that supposedly showed that our observations of Polaris are possible on a flat Earth. So what I'm going to do now is I'm going to talk you through trigonometry to the point where you can use this yourself. And I want you to apply it to the picture you show me in the debate, and then you'll just see yourself as you're trying to apply it exactly what the problems are and why that picture you showed us really was about as much use as a chocolate fire guard. Hopefully you'll also see that our observations of Polaris do not work on a flat Earth. So let's begin. We have a triangle. Polaris is going to be here. We are going to imagine we're stood down here on a flat Earth. And this is the angle that we're going to be viewing Polaris at in the sky. Now we're going to start to label the sides of this right angle triangle we've got. And we might remember from school that the longest side of a triangle is called the hypotenuse. So I'll label that with a H. We might remember that the other two are called the opposite and adjacent. But one thing that kids really hate is figuring out which is the opposite and adjacent because they do change. And they change depending on which angle we are given. Now we're given this angle. The side that is opposite that angle is the side we're going to call the opposite. So if I was given this angle here, this would be the opposite. So I now have my hypotenuse and my opposite, which means the third one must be the adjacent, H, O, and A. And then I'm going to look at these three equations I've got here. And these three equations here have the letters H, O, and A in them. They are going to be the equations we use to figure out the length of a triangle or even an angle inside the triangle should we need to. Now, in the debate, I mentioned the words sine and cos and tan to you, and you didn't really have a clue what they were. So I'm not going to go any deeper than just say they are buttons on a calculator. I've even drawn them here as buttons. That's how they look on the calculator. They refer to the angle, and that's all I'm going to say until we get a little bit deeper into this question. So, what is the question going to be? Well, maybe we sit down and somebody tells us that the length of this is 20 centimeters, and they want us to figure out the length of the opposite. We can't do it just with that. We need to know this angle as well. So let's say that angle is 30 degrees, and now we're good to go. What I'm going to do is I'm going to look at these three equations at the top, and I'm going to decide which of these three equations I'm going to use to figure out the length of this opposite side of the triangle, or what will be the height to Polaris. So how am I going to do it? Well, if I know I want to work out the opposite, I'm going to look at these three equations here and see which one has got the letter O in. And in fact, there's two. Two of them have got the letter O in. So I could perhaps maybe use one of those two, but definitely not this one because it doesn't have the letter O in, so it's not going to give me the opposite. Now, which one do I use? Well, let's look back at my question and let's ask myself, what else do I know? And I know the length of this side of the triangle here. That was the adjacent, remember, this is 20 centimeters. So which one of these not only has O in, but also has the adjacent in? Because we know that. Well, it's not that one, it's this one here. So what I'm going to do is I'm going to get rid of that. And now I'm ready with my equation to plug my numbers in. So what does this equation tell me? This tells me that the opposite equals that t, that strange t thing, which we'll get to in a minute, times the adjacent. So what is that t? Well, at the level that we're at the minute, Brandon, all we need to know is that level, that letter t represents this button on the calculator. And you're going to press that button on the calculator. And what will happen when you press it is your calculator will say this. It will say tan, and it will come with a bracket next to it. And you put in the size of the angle that we know. Okay, so remember I said these refer to the angle. So we put in the size of the angle we know, tan 30. And then we close our bracket and we times it by our adjacent there, which is 20. Now, I'm not going to do this for you, but if you do that in a calculator yourself, get a little bit of practice, and you draw out this triangle to scale, you'll realize that the length that you are given for the opposite, which is this here, is exactly what this equation tells you because the equation works. And I want you to practice this over and over and over and over again, drawing out lots of different right angle triangles with lots of different lengths here for the adjacent. And you'll see that it predicts every single time exactly what this side of the triangle will be because it works. Trigonometry does work. But then I want you to do something different. I want you to come back to this original question, and instead of having 30 degrees as our answer, as our angle, I want you to change it to 29 degrees, and then 28, and then 27, and then 26. And I want you to keep changing this. And what you'll notice is that this length of the triangle here changes. Think about the significance of that. If the length of this is changing. This is our distance to Polaris, isn't it? So if the length of this is changing when the viewing angle changes, that means that Polaris has to be in a different position physically in the sky for every observer at every latitude on Earth. It's ridiculous. I want you to take this idea and apply it to the photograph that you showed, or the picture you showed me in our debate. And what you realize is you're not given any distances here on the bottom. And that is because if you were given the distances, and not just the angles here, we could apply trigonometry to it and show that it doesn't work. I hope that helps, Brandon. I hope you learn a bit of trigonometry, and then I hope you realise the significance of trigonometry and the angles of Polaris and how it rules out the possibility of the Earth being flat. And then I hope, actually, that you stop telling people that things like perspective and angular size can be worked into trigonometry maths to show that Polaris observations work on a flat Earth, because that was a hefty amount of word salad with literally zero knowledge source. I like that. Anyway, bye-bye.
Thanks, Catz. I'm glad we were able to clear that up for our good friend Brandon here. And be on the lookout for that chill check in the mail. Excuse me. Anyway, once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video. And check out the rest of my videos if you're interested. And as always, peace.
Destroy shit, pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.